Good afternoon, my dear students. Today I will take your class related to problematic soils and their management. And the today topic is reclamation and management of acid soils. So I have given different outlines like objective, introduction, definition of acid soils, nature and classification of acid soils, sources of hydrogen ion, this distribution of acid soils in India, factors of formation of acid soil, characteristics of acid soil, development of acid soils, effect of acidity on plants, liming, benefits, factor affecting lime requirement, reclamation of acid soils, management of acid soil, conclusion and learning outcome along with the references. Now first I want to tell you what is the objective of this delivering the lecture, to introduce the students about reclamation and management of acid soils. The acid soil of India covers a very large fraction of country. About 30% of the cultivated land comes under the category of acid soils. Out of total geographical area of about 329 million hectare, the net cultivated area in India is 149 million hectare. It is estimated that there are 49 million hectares of acid soil, which is nearly one-third of the cultivated area of India. Now let us define the acid soil. What is acid soil? Acid soil are defined that if any soil has a pH of less than 7, then activity of hydrogen ion concentration in the soil is disturbed, and the higher the H ion concentration, the lower will be the pH value of the soil. Now, in arid soils are associated with a number of toxicities such as aluminum, magnesium, iron, and deficiency of molybdenum and other plant restricting condition. I have given some photograph of the acid soil which you are seeing. Mostly this is the laterite soil, red soil. Now, nature of classification of acid soils. Classification of soil acidity according to the presence of ions. There are three types of soil acidity. First is active acidity. In this activity, H ions remains freely present in soil solution and producing limited acidity. It is a measure of the hydrogen activity in the soil solution given time. In such acidity, hydrogen ion is very small in compared to exchange and residual acidity. It is very important because of the environmental to which plant and microbes are exposed. Second is exchangeable acidity. In very acidic soils, exchangeable H and aluminum ions are presented in large quantity. The quantity easily exchangeable of H and aluminum ion are quite less in quantity, and it is a moderately acid soils. In this acidity, high amount of lime stone is required to neutralize the acid soils in comparison to active acidity. Mostly what happened, the clay colloid is adsorbed with the aluminum and hydrogen ions, and if this is react with the potassium colloid, then the potassium is adsorbed on the colloid, and in the last aluminum oxide is formed. Third is residual acidity. In this acidity, the soil after active and residual acidity has been neutralized. Now, residual hydrogen and aluminum alone are found in exchangeable form by organic matters and in silicate clay. Residual activity commonly for greater than active of the exchangeable activity and the lime acid swell, and the lime requirement is very high, about 1000 to 10,000 units, greater than the active and exchangeable activity. Now, source of hydrogen ion. Swell acidity is caused by the insoluble hydrogen ion exchangeable H are present in the swell to neutralize the negative charge arising from isomorphous substitution. They are displaced by the cation, which is added fairly high concentration. Now, first is moderately acid swells. This moderately acid swell, the exchangeable hydrogen ion are main source of hydrogen in moderately acid swell, and it is the pH of the swell is in between 5 and 6.5. This is 6.5. Now, moderately acid swells have higher percentage of the base saturation, calcium and magnesium. Then the strongest acid swells, aluminum, can no longer exist as ion, but it converted into aluminum hydroxide. You just see the aluminum and OH ion when mixed they form the AlOH ion, and AlOH after hydrolysis they form in the aluminum hydroxide. And hydroxide ions due to the swell solution aluminum hydroxide ion produce H by the hydration or by the hydrolysis. Now AlOH twice plus H2, it is AlOH thrice is formed, and you just see that there is concentration of H ion. So the next is strongly acid swell. It becomes soluble, very soluble in a very acidic swells. pH is less than 5, and at higher it is highly tightly bound by organic matter and present in the form of aluminum or aluminum hydroxide. These exchangeable ions are adsorbed by the negative charge and collides. They adsorb aluminum ions are in equilibrium with aluminum in the swell solution. You just see the collide, it is adsorbed with the aluminum, and this when aluminum is hydrolyzed, then there is a this aluminum is replaced by hydrogen is replaced by the aluminum. Now acid sulfate swell. This swell is less than 3.5 pH value. This is a very problematic swell. Acidity is due to the not decomposition of organic matter, and there is a formation of the sulfuric acid and aluminum sulfate. Mostly this H2 is produced by oxidation of sulfur and sulfide. This swell is found in some of the low-lying area of Kerala. So this is the distribution of acid swells in India. Mostly in laterite swells, the pH value 4.8 to 7.8. It is about 12.65 million hectare. Now this laterite and laterite 5 to 7 pH. It is 11.80 million hectare. And third is mixed red and yellow swells, acid swell 5.5 to 6.5, and it is 23.60 million hectare. And Panagenic swell, mostly it is pH is 5.2 to 6.7, and the area is about 8.90 million hectare. And ferromagnetic red rocky swell, mostly it is 5.2 to 6.7, 0.6 to 20 million hectare. Podzolic swell, the pH value is 4.5 to 6.5, and the area is 22.47 million hectare. Next is green and black brownish swells, Gir pot 4.3 to 6.5. The area is about 8 million hectare. And black brownish peat which is totally undecomposed soil, and pH value is 3.5 to 4.5, and the area is 0.20 million hectare. The total area is about one third of the cultivated area. Source Mandal, Ital, 1975. Now, factors of formation of acid soil: mostly leaching of soil due to high rainfall. Mostly what happened in high rainfall area, due to high rainfall, all the bases are leached down to the lower horizon, and the hydrogen ion is adsorbed on the colloid, and mostly they create the acidity in the soil. Now the microbial activity, mostly what happened due to low pH, some microbial activity is not properly done, and they are not use them nutritional any activity or any decomposition activity, so that's the mineralization and decomposition of organic matter is very poor, and the nutrient availability is also very poor. Acid parent material, mostly if the any soil is formed by the parent material which are in acid in nature like granite, then in the long run it will form the acid soils. Now removal of bases by crops. If some crops which require very high bases, they remove the bases from the soil, then mostly the acidic soil is formed. Now the continuous application of acid forming fertilizer. There are mostly the farmers are using this calcium ammonium nitrate, ammonium sulfate, ammonium nitrate. So mostly this is a pH. This pH is mostly the pH is below 7. So this fertilizer mostly create the acidity. So just to see, when colloid is adsorbed by calcium, you are going to apply the ammonium sulfate, then this ammonium is adsorbed on the colloid and calcium sulfate is formed. Now characteristics of acid soil. Acid soil which have very little amount of electrolytes, slightly is dispersed condition, as such clay widely carried out downwards in profile and form pan. Water soluble aggregate is also not formed, which create unfavorable condition, and heavy soil may also get puddled. Leaching of the clay to lower horizon is quite apparent, and surface soil structure is very light and have low water holding capacity and high permeability. Acid soil of MP ranges from sandy to clay loam. Acid soil have lesser amount of basic cations, that is H adsorbed on the clay colloids, reserving acidity to the cause of buffering it, and acid soils buffering capacity depends on the nature of the clay minerals. Montmorillonite clay, this capacity minerals have more buffering capacity than the elite and colonite clay minerals. As the acidity of soil increase, most of the plant are poorly growth. It is only due to the presence of toxic substances and low availability of plant nutrients. Now in acid soil there is a toxicity of aluminum and magnesium and iron. In acid soil the amount of phosphorus is low, but there is a enhance of the fixation, phosphorus fixation. The organic matter and nitrogen content of acid soils show extreme variation, and depending upon the nature variability, generally laterite soils are low in organic matter and aluminum. Nitrogen is fixed in acid soil at lower rate, at low pH. Nitrification in acid soil decrease with acidity. The rate of nitrification depend on Ca content. Very little N fixation is occur in acid soil with low pH due to unfavorable condition and azoto vector rarely exists in the below 6 pH. Now, development of acid swells. There are 4 phases of the development of acid swell. One is lateralization. The process of formation of lateralization swell is known as lateralization. In this process, due to erosion of bases, silicon is low on the surface of the profile, and aluminum oxide and iron oxide are leached down. This process is more common where rainfall ranging 2000 to 15 millimeter and climate is in humid arid region. The apparent rocks are decomposed and leached down rapidly. Laterite swell is rich in iron. Podzolization is a process due to decomposition of soil organic matter. Carbonic acid is formed. Due to high rainfall, aluminum and iron oxide are leached down and the solubility is increased, which lower down the solubility of the silicon. The swell formed by this carbonic acid is known as podzol. These swell are low in calcium. Now, third process is the leaching. In high rainfall area, the soluble salts leach down below the profile and base are leached down, and there is the adsorption of H ion on colloidal clay. Partial organic matter decomposition and accumulation in Himalayan region due to low temperatures, soil organic matter is not decomposed properly and soil organic matter amount is increased, which lead to the accumulation of soil organic matter. Now, effect of soil acidity on plant. Direct effect, toxic effect of H ion on root tissues, influences of soil acidity on permeability of plant membrane for cations. Now, disturbance in the valence between basic and acid conditions through the roots. Now, indirect effects, adverse effect of the availability of phosphorus, copper and zinc, high solubility and availability of aluminum, magnesium and manganese and iron present in toxic amount due to high soil acidity. Beneficial activity of soil management adversely affect. Liming. Liming means aiding in the soil any calcium or calcium magnesium containing compounds, and it is capable of reducing the activity, and soil liming is added in acid soil primarily for 3 purposes: to apply calcium and magnesium as a plant nutrient, or to reduce the toxicity of aluminum, magnesium, and manganese and iron, to increase the pH of acid soil and make the available nutrient to plant. Benefits of liming. It neutralizes H ions and increase OH ions, neutralizing soil's acidity by raising soil pH. It reduces the base unsaturated of the acid soil, whereby calcium and magnesium ions are adsorbed on the clay colloid, replace H and OH ion. This is calcium, magnesium and other bases become more available in the plants. It decreases the solubility of aluminum, magnesium and iron, and thus reduce the toxic effect of plants. It renders phosphorus and magnesium in a more available form. P fixation by soluble Fe and aluminum is stopped. Molybdenum facilitated the symbiotic nitrogen fixation in acid soils. It decreases the solubility of zinc, Cu and B in acid soils, and they may be toxic in concentration. Some K may also be released for plant utilization. It increases the rate of decomposition of organic matter, due to which plant nutrient is released. Nitrification of ammonia and nitrate is increased. It favors the formation of crumb structure of soil and increase the aeration, water penetration and water holding capacity. The effectiveness of fertilizer and manures is increased, especially this ammonical nitrogen fertilizer. It prevents the destruction of the clay minerals. Overliming. Use high doses of liming material than the requirement. Create overliming, which is very harmful. The adverse effect of overliming is given as under this hindrance of availability of P and molybdenum, availability of iron, manganese, copper and zinc is decreased. Formation of complex and insoluble P, which is reduced. The availability of P, hindrance in availability of B in plant due to increase in soil pH, adverse effect on physical chemical properties. K uptake may be reduced. Efficiency of liming material. The factors influencing the effectiveness of the efficiency of any liming material are this chemical composition, purity of the materials and degree of the fitness of the materials. The chemical composition of the materials expressed in terms of calcium carbonate equivalent is known as neutralizing value. This can be calculated by this formula: calcium carbonate equivalent molecule weight of calcium carbonate plus into 100 divided by molecules weight of the calcium. Suppose that there's 100 divided by 56 into 100, the 178.6 this kilogram of the percentage of the amendment will be utilized. The calcium carbonate equivalent or neutralizing of the different liming material. The COC3 equivalent of neutralizing value of different liming material are given in this table. Neutralizing value of commonly used liming material. One is limestone, that is calcium carbonate. Neutralizing value is 100%, and the quick lime, this is CaO, and neutralizing value is 178, and slag lime CaOS twice, it is 135%, and dolomite calcium magnesium carbonate, it is also this 153, and basic slag about it is 50%. Now method of liming application. Liming should be applied before plowing or applied on plowed land, then mixed in the soil by disc. In case of large quantity of lime are to be applied in small quantity 2 or 3 times rather than one half application. In strong acid soils, larger dose of lime are required. Half of the quantity should be applied before plowing, and remaining half of the lime should be applied after plowing. When lime requirement is 2 ton less than, entire amount should be applied at one time 1 month before sowing of the crop. When only one application of lime is to be given, it should never be given before plowing with a furrow turning plow. Now the reclamation of acid soil, there are so many amendments available in the market like limestone, calcium carbonate, quick lime, calcium oxide, hydrated slag lime, calcium hydroxide, dolomite lime, calcium magnesium carbonate, blast furnace slag CAS, and these miscellaneous sources are the wood ash, pressed mud and paper industry byproducts. So these are the amendments which can be used for the reclamation of the acid soils. Now factors affecting the lime requirement. Now the pH value. If the pH value is low, then the acid soil will require the more amount of liming material. If pH value is normal or pH value is 6.5, in between 5.6 and 6. There will be very little amount of the lime is recommended. Now soil structure. If the texture is fine, then some small quantity of needed, but if that texture is coarse, then the quantity of lime material is required more. Amount of organic matter, if there is a this low organic matter, then the this limey material will be applied in more quantity. If it is less, then it should be applied in less quantity. Types of clay fraction is very important. If there is more clay, then you have to apply more lime, calcium carbonate, or any amendment. And type of the crops. So there are acid tolerance crop and this basic tolerance crops. Mostly in acid tolerance crops must be applied, must be given after the amendment or after the reclamation. Now reclamation of acid swell. First is ground limestone. When it is applied in acid swell, a part of calcium carbonate undergoes solution and combines with the carbonic acids to form calcium bicarbonate. Likewise, the calcium carbonate plus this H2CO3, it forms calcium H2SO3 twice. Calcium bicarbonate in the solution react with swell, collide, and freely H is formed. Now, after that, the this clay miscellaneous or colloidal particle adsorbed with the H ion. When you react with the calcium, this bicarbonate, then the calcium is replaced by the calcium is replaced by the aluminum or iron, and in the last H2O or CO2 is formed. So while some portion of the limestone goes into solution, a part of the applied limestone comes in close contact with the swell, collides in solid condition. Under these circumstances, this adsorption takes place with swell, collide also, and there is a colloidal swell collide. There is a adsorption of H. And now when we react with the calcium bicarbonate, it forms the calcium is adsorbed on the clay miscellaneous, and then H2 and CO2 is formed. As the above reaction of limestone proceeds, carbon dioxide is freely evolved, and the absorption of the calcium and magnesium raises the percentage base saturation of colloidal complex, and thus by pushing up the pH of the swell solution. Now quicklime, which is known as burnt lime, when limestone is heated to a temperature of over 8000 degrees centigrade, the calcium carbonate decomposes, yielding calcium oxide. For 100 kg of calcium carbonate, burnt 56 kg of the calcium oxide is formed. When quicklime calcium oxide is added to any acid swell, it changes to bicarbonate from as it goes into solution CaO plus H2O COH twice, and this COH twice again react with the carbonic acid, and it forms calcium bicarbonate plus H2O. Calcium bicarbonate thus reacts with the swell, collide, and calcium ion are adsorbed in the colloidal complex. Now suppose that there is a colloidal complex and it is adsorbed by H. When you add this calcium bicarbonate, the calcium adsorbed on the colloidal complex, and H2O and CO2 form, and due to the adsorption of calcium, the pH will be increased. Now slag lime, it is produced by adding water to burnt lime, CaO plus H2 plus COH2. For every 56 kilogram of calcium oxide, 18 kg of water is needed for proper slagging to yield 74 kg of hydrated or slag lime. During the process, considerable amount of heat is generated. When slacked lime is added to an acid soil, it combines with carbonic acid to form calcium bicarbonate in solution. Likewise, COS twice 2H2CO3 plus CaSO3 twice plus 2H2O. Calcium bicarbonate in solution react with the soil colloid and the calcium ion are adsorbed in the soil complex. For example, colloidal complex is adsorbed by iron, hydrogen, and when you react with the calcium bicarbonate, then the calcium will be adsorbed and clay mesylate and the pH will be more. As the reaction proceeds, CO2 gas is freely evolved. The adsorption of calcium in the soil colloids raises the soil pH. Now, management of acid soil. First, use of the basic fertilizers such as sodium nitrate, basic slag, and calcium ammonium nitrate. So these are the basic nature of the fertilizer. So it is one of the very good method for using the basic fertilizer to reduce the acidity of the soil. Now, to grow acid tolerance crops and cultivars with the due emphasis on diversification. Now, agroforestry is an emergency option of acid soil, especially in eastern hilly ecosystem. It is a best option. Now, integrated nutrient management system applied in acid soil. So you should be apply the combination of the nutrient, this organic, inorganic, this biofertilizer, even green manuring. So this all integration should be done to improve the acid soils. Now, easily decomposable plant residues, whatever the plant residues is harvested, that should be mixed in the soil, or some green manuring can be done of senhemp or this sesbania. So it also helps the organic matter content in the soil after decomposition. There is a growing of some acid tolerance crops like berseem, sugar beet, cauliflower, cabbage, bean, muskmelon, lucerne. Acid resistant soils are this mustard, rye, and buckwheat. In management of moderately resistant, maize, oat, potato, barley, soybean, and wheat can be grown. Now, there should be, if you want to increase the acid soil or improve the acid soils, so mostly in first year you take the groundnut plus linseed. Second year crop rotation should be maize plus pigeon pea. In third year it should be maize plus pigeon pea. Fourth year it should be direct sown rice plus linseed. And fifth year rainy season potato plus linseed. Now I want to conclude it that for reclamation of acid soil, easily available liming material should be applied after periodical soil testing for this requirement. Use of calcium carbonate as a liming material is the best option. For appropriate management of acid soil, use of basic fertilizer and better crop rotation along with integrated nutrient management and easily decomposable plant residues could be incorporated. Now, the learning outcome of this lecture is the students could be quite competent to know the nature, formation, characteristics, reclamation and maintenance management of the acid soil of their region. They adopt latest reclamation and management technology of acid soils to better harvest of the crop in the such soils. For this preparation of this lecture, I have already consulted so many references. One book is B.C. Srivastava, Management of Problematic Soils, and another is B.N. Sahai, Fundamental of Soil Science, and Pandayan, Management of Indian Soils for Sustainable Agriculture, Mandal Lassi, Ital, Acid Soils of India, and Liming, ICAR Technical Bulletin 51. Now this Brady, NC, and the Nature and Properties of Soil, 10th edition, 20th Sol of India, New Delhi. So now there will be a webinar on the next day, mostly next week, mostly on Thursday. As scheduled time 3:30 to 4:30. You must prepare uh, with this reclamation of acid soils and their management, and whatever your queries you must ask in that seminar class, and you must go through the PPT and this video, already uploading video, so you can get some better idea, and you can ask and interact with me about the reclamation and management of acid soil. Thank you very much. चलो